Welcome to qnawire.
Chapter 16, Problem 126. Using dissociative constants from Appendix D, determine the value for the equilibrium constant for each of the following reactions. So for part 1 of A, we have our dissociation of our HCO3 minus, and that's going to go to CO3 2 minus and an H plus. And when we look this up in the back of the book, our Ka value for this is equal to 5.6 times 10 to the negative 11. And then also we're looking up for our OH. So we have our OH and then we have an H from over here that is being added. So our H plus our OH goes to H2O. And whenever we look up our information for that, we get a Kw of 1 times 10 to negative 14. Sorry, not negative 14, just 14. So whenever we're trying to find our K equilibrium, we're going to do Ka times Kw. And when we multiply these two values together, we get 5.6 times 10 to the negative 11 times 1 times 10 to the 14th. And our answer, we get 5.6 times 10 to the third. And that would be for part 1. In part 2, we have the dissociation of NH4 plus going to NH3 plus H plus. And then we also have the CO3 2 minus plus an H plus goes to HCO3 minus. And so the Ka in the back of the book for the first one is 5.6 times 10 to the negative 10th, where the Ka for Ka2, the 1/2 of Ka is equal to 1.785 times 10 to the 10th power. So then whenever we plug this in, and the reason why we have 1 over Ka2 is because this is in a reverse reaction of what we put into the, what the actual equation is in the back of the book. So I took 1 divided by the Ka2 of this, the value that was in the back of the book. So when we use the same equation that we used earlier, our K equation is equal to our Ka times the 1 over Ka2. We'll get the 5.6 times 10 to the negative 10 times 1.78 times 10 to the 10. And we get 10 for this value as well. So for each of these equations, we were had a K equilibrium of 5.6 times 10 to the third and a K equilibrium of 10. And it asks us that we usually use a arrow bar forward for a reaction when it is greater than 1. So which products escapes from the system? So when an equilibrium is never established. If we follow this convention, which of these equilibriums may be written with a single arrow? And this answer, both of them would be. Have a single arrow due to them both being greater than 1.